In this video, I want to have a look at finding inverse functions. So there's two steps when we're doing this. Essentially, we want to switch the input and the output of our function. So the first thing we're going to do is we're going to switch the x and the y around in our equation, and then we're going to rearrange the equation to make y the subject. You could also do it in the other order. If you had your original function, you could rearrange it to make x the subject, and then switch your x and y. It's up to you which way around you do it. If we have a look at an example, we're asked to find the inverse function. Our original function is y equals 1 over x minus 3. So to find our inverse, we're first going to rewrite it, but with x where y is and where x is. So we're going to have x equals 1 over y minus 3. And then we want to rearrange this to make y the subject, because usually that's how we write our functions. So I'm going to multiply both sides by that y minus 3. So I'm going to have x outside of y minus 3 is equal to 1. Then I'm going to divide by x. So I'm going to have y minus 3 is equal to 1 on x. And then I'm going to add 3 to both sides. So I'm going to have 1 on x plus 3. Let's just have a look at what that looks like graphically so that you can see that they are still reflections of that line y equals x and they are inverse functions. So in red here we've got our original function y equals 1 over x minus 3. If we draw in blue our inverse function that we found, and then if we put that line y equals x in there, you can see that they're reflections over that line. So again, if you imagine folding that whole graph in half along that line, then they would lie exactly on top of each other. So our second example, we've got y equals x plus 1 over x minus 1. So to find the inverse, I'm going to write down x equals y plus 1 over y minus 1. Now I'm trying to make y the subject. I'm going to start by multiplying both sides by my y minus 1. But I want to get all my y's together. So I'm going to expand this out. And then I'm going to pull all my y's over to the left-hand side of the equation and everything else over to the right-hand side. So xy minus y equals x plus 1. And then I'm going to pull y out as a common factor. So I'd have x minus 1 in brackets, and I've got x plus 1. That's an equal sign. And then our last step, we'd rearrange it so we have x plus 1 over x minus 1. But if we have a look at that, that's exactly what we started with. So what we've found is that the inverse function is exactly the same as the original function. Let's have a look at the graph and see why that happens. So this here, I've got drawn my original function in red, and then of course, because my inverse was exactly the same, they're just directly on top of each other. But the reason that's happening, if we put this line in here, is that you can see that that curve, that function, is symmetric about that line. So if we zoom out, you can see that if we were to fold the function in half, the function sits on top of itself anyway. It already has symmetry about the line y equals x. So because it has that symmetry, the inverse is going to be exactly the same as the original. And that'll happen for any function that has symmetry around the line y equals x. It is important to know that not all functions have inverse functions. So sometimes when we find the inverse, we actually end up with a relation and not a function. So remember, a relation doesn't pass that vertical line test. Let's have a look at an example. So we've got a function here that we're really familiar with. It's just y equals x squared. If we add in the line y equals x, so this is what we're going to reflect our function over, then our inverse would look like this. So you can see that that's not a function because it's not passing that vertical line test. So we can actually tell that before we even find the inverse, we can actually tell that it's not going to give us a function because if we look at the original, we can do what's called the horizontal line test. So if our original function doesn't pass the horizontal line test, which means that if we were to draw, or it's possible to draw a horizontal line through our function and it'll cut our function more than once, if our original function doesn't pass the horizontal line test, then that means our inverse function isn't going to pass the vertical line test. So in these cases where it doesn't pass the horizontal line test, what we can do is we can restrict the domain of our original function so that it will. So we need to restrict the domain so that our function is either monotonic increasing or monotonic decreasing. So that means it's always increasing or always decreasing. So that means we have to pay attention to where our turning points are. Another way of saying all that is that we need our function to be a one-to-one function. That means for every y value, there's only one corresponding x value. Let's have a look at an example. So if we go back to looking at the function y equals, or f of x equals x squared, We know that that function doesn't have an inverse function, but if we restrict its domain, we can. It can, or it will. So normally our parabola would look like this, but if we decide to only look at when x is greater than 0, so we're only looking at this part here, then that red section will have an inverse function. So the way we can find it is we can start off doing the same thing. So our original function is y equals x squared. So our inverse, we'd have x equals y squared, or we could rearrange that to y equals plus or minus root x. But because our domain here was restricted, that means that the range of our inverse is going to be restricted. So our range is going to be y is greater than or equal to 0. So it's not going to be plus or minus root x, it's just going to be the square root of x, the positive square root of x. And that's because if we were to draw the function x equals y squared, if we were to draw that, or you could write it as y equals plus or minus the square root of x, our function would look like this, which is what we got when we tried to find the inverse of the whole function. But what we want is just this part. So we've just reflected that red bit across the line y equals x to get this part here. So let's have a look at finding inverse functions.